Hello friends, welcome to YourPedia Education. As you know, BEL announced their exam date, that will be on 31st of May. Right, today is 13th of May. So we have only 17 days for this exam right now. Right, if you are not preparing for this exam and you want to correct this exam, that for that one we are going to launch a module. Right, I think we launched this one today. We are going to launch that module, that is practice through questions, right, or you can say perfection through questions. Right, in this module what we are giving you, we are giving you 4,000 and 5,000 questions, around 4 to 5,000 questions in the form of some question in the form of video, in which I am trying to touch all the topics through the questions. Right, so these videos are available for that module. Right, for each subject around 150 to 200 questions video is available. Right, in that video we are discussing each and every question in detail, right, so that you will understand that what is the concept behind that. Right, another thing which we are going to provide you, that is a test series. Right, test series also available, and one more thing, we are provide you the practice questions. So basically in this complete module you are going to get around 4 to 5,000 questions. That is really important, and this module is most important for all of you which are going to give your BEL exam and you didn't prepare for that one. Right, and now through these questions you can practice. And one more thing, this exam is not like that they will ask you in depth question, they will ask you more questions but less depth. Right, and so for that one you need to practice more and more questions. Right, so for you we are going to launch this module. See, अगर हम बात करते हैं BEL की, तो BEL के एग्जाम में आपको गेट लेवल की चीजें नहीं पढ़नी है, आपको सारे कंसेप्ट्स जो हैं वो आपको टच करने हैं. राइट, वन मोर थिंग दैट इज इंपॉर्टेंट, दैट फॉर दिस BEL एग्जाम देयर आर GPS questions are also there, and there are microwave questions is also there. So we are going to cover all of these things. Right, we are not strict to the gate syllabus, we have to read that one. And another thing that is important is cutoff is not going to be less, it is going to be high. Right, but what you have to do, you have to do the practice more questions, right, as much as you can do. So for this module today we are going to discuss some questions from EMFT, and which may be asked in your exam. So let's start. That first question is, which of the following is not correct? Which of the following is not correct? The symbols have their usual meaning. Right, basically the del cross E, these are all are the Maxwell equations. As you know, these all are the Maxwell equation, and he is asking that which equation is not correct. If you know the Maxwell equation, the first Maxwell equation, that is represent the Faraday's law, that is del cross B is equals to minus del B over del T. Right, the second equation, this is Ampere's law. The third equation, that is represents the Gauss law, and the fourth equation is that del dot B is equals to 0, that is called as non-isolated magnetic charge. Right, so which of the following is not correct? I think there will be something that is X, not T. This is X, so that's why your answer is B. So in this one, you have to do one thing, you have to revise all the Maxwell equations. Right, so what are the Maxwell equation? You revise them. He will directly ask you that which of the following Maxwell equation is not correct, like this. Right, move to the next question. The Maxwell third equation is given by, right, see the Maxwell equation, the first equation which we derive that is for from the electric field. Right, that is del dot D is equals to rho V. This is your Maxwell first equation. The second Maxwell equation is del dot B is equals to 0. The third Maxwell equation, del cross E is equals to minus del B over del T, and the fourth Maxwell equation is del cross H is equals to J plus del D over del T, right? And in the previous example, if I go to the previous example, that is del D over del T. For the correct equation, that is del D over del T, not del E over del T, right? So that's why this equation is not correct. And here we going to check that the third Maxwell equation is what? That is del cross E is equals to minus del B over del T. So this is your third Maxwell equation. Remember that, this is important. So you must know the order of differential Maxwell equation: first Maxwell equation, second Maxwell equation, third Maxwell equation, and fourth Maxwell equation. Remember one more thing, sometime he may ask that which of the following is Ampere circular law, right? So Ampere circular law represents which Maxwell equation? That is del cross H is equals to J plus del D. D is electric flux density, and what is the relation between D and E? That is epsilon naught E. Remember that. So sometime he may ask you that which of the following represents the Maxwell equation which was derived from Ampere's law, right? So you know this one, which equation we derive from there, and you should know that which one is the first equation, which one is the second equation, and third equation, like that. Okay, next question. For a static, remember the meaning of that one: static electric and magnetic field in a homogeneous source free medium, which of the following represents the correct form of Maxwell equation, right? Whenever you have a static electric field, right, static electric field and charge free medium. So basically, if I am talking about the charge free medium, that rho v is going to be 0, and electric field and magnetic field is static, means that electric field and magnetic field are not going to be a function of time. So it means if these are not function of time, go to the previous equation, the first equation, that rho v, because it is a source free medium. So source free medium means your del dot rho v, yeah, that is source free medium, right? Del dot rho v is equals to 0, right? First equation. Then del dot B is 0, that there is no change. One more thing, electric field and magnetic field, remember that both are not function of time. He is giving you that they are static. So it means if you take the derivative with respect to time, that is going to be 0. If you take the derivative of this one with respect to time, that is also going to be 0. So what we can say, that del cross E is going to be 0 and del dot B is going to be 0. See, del dot B is always 0. That del dot B represents what? That if you have a magnetic poles, right, if you have a magnet, and if you cut the magnet, then there will be again south and north and south pole. It means what it tells you, that north pole and south pole cannot be exist independently. That is the meaning of this one, right? So if we talk about this one, so what we can say, that for a static electric field and magnetic field in an homogeneous source free or charge free medium, the Maxwell equations become what? So which one? That will be del cross E is going to be 0 and del dot B is going to be 0, right? Next. In a charge free space, the Poisson equation results which of the following equation? See, basically if I am talking about del square V is equals to what? Minus rho v upon epsilon. This equation is called as what? This equation is called as Poisson equation. If you have a charge free medium, inside the charge free medium, this rho v is going to be 0. Inside a charge free medium, your rho v is going to be 0. Whenever your rho v is going to be 0, it means this equation is converted into del square v is equals to 0. So this equation represents what? This equation represents the Laplace equation. So basically, whenever you have a Poisson equation and you are dealing with a charge free medium, inside the charge free medium, your Poisson equation is converted into Laplace equation. So what will be the answer? Answer will be see that your Poisson equation is converted into Laplace equation. Next is the magnetic flux phi linked with a coil at an instant of time t is given by phi t is equals to this one. Then induced EMF in the coil at the instant of 2 seconds. So basically the induced EMF, right, induced, that is going to be minus del phi by del t, and phi is given to you, so you have to take its derivative. So it's going to be minus d upon dt, and that is 2t square minus 20t plus 40. When you take its derivative, that is going to be minus outside, that is 4t minus 20. Now you have to calculate this value at t equals to 2. So when you replace t equals to 2, that is going to be minus outside and 8 minus 20. So that is going to be 12 volt. So basically whenever you have to calculate the induced EMF, right, you have to use induced EMF is equals to, that is called as Faraday's law. So induced EMF is minus d phi by dt. Next, in an infinite plane at y equals to 6, as you have a surface charge density, then the associative electric field. So basically you have a infinite charge density like this, okay, at x equals to y equals to 6, right, y equals to 6 centimeter, y equals to 6 meter, we have a charge density of surface charge density rho s is equals to 1 upon 600 pi. So basically y axis is perpendicular to this y is equals to 6 plane. So all the magnetic field, electric field are always perpendicular to this surface. Either they are going to in j direction, either they are going to minus j direction. So from the options you have to choose that. Basically only j is written there, it means he is calculating the electric field above, because it can't be k, it can't be I, right? And what will be the value of electric field? See, don't think this is incomplete question, this is a complete question, that's why I put it here, right? It is important to understand the things, because from the options what we understand that electric field, this is y axis is perpendicular to this y equals to 6 planes, remember that thing, right? So y axis is perpendicular. Whenever you have a surface charge density, the electric field is given by rho s upon rho s by rho s by 2 epsilon, right? Epsilon is also there. And what will be the direction? Direction is a n cap. So right, so basically try to understand this question. If I am calculating the magnetic field at this point, the a n cap is a unit normal vector which is going from this this plane to this towards this point, right? If my point is below, then this a n cap is going to be downward direction. So it will depend where is your this point P, right? So basically this point P is lying above, so it means the electric field strength is going to be how much? Is going to be rho s, that is 1 upon 6000 pi and 1 by 2 epsilon naught, right? So remember 1 upon 4 pi epsilon naught is going to be 9 into 10 raised to power 9. So from this one we can calculate this epsilon naught is going to be, or either you can directly calculate 1 upon epsilon naught, right? I am going to calculate this 1 upon epsilon naught. So this 1 upon epsilon naught is going to be 36 pi into 10 raised to power 9, and this charge is given in microcoulomb. So what we have to put it here? Micro. We put the rho s charge density and 10 raised to power minus 6. So these values when you replace, you can check, yeah, that is 1 into 10 raised to power minus 6, 600 pi. So if you replace epsilon naught, that is calculation are complicated, but if you replace 36 pi into 10 raised to power 6, so that is become 1 10 raised to power minus 6 divided by 6000 pi into 2 into. right? This 36 pi into 10 raised to power 9 is going into the numerator. So pi will cancel out, and this has become 10 raised to power 9. I am cancelling this, that is also cancel out. So this is 36 by 12. So that is going to be 3, right? So what will be the answer for this one? That is 3 J cap volt per meter. So you can go like this, right? With the symbol having their usual meaning, which one of the following relation is not correct? Which one of the following relation is not correct? So basically, if you go for this relation, this is not correct, because del cross E is going to be minus del B over del T. Remember, he is missing the small thing there, because B is how much? That is mu naught H. So if you replace there, then del cross E is going to be minus mu del H over del T. So if we integrate both the side, this is with respect to ds, this has become closed line integral, that is E dot dl, and this has become minus mu del over del T, and this is H ds. So there is what? Mu is missing. There should be a mu here. So if mu is missing, so that means this answer is not correct, right? Like that. The relationship between electric field and current density J in the conducting medium. See, whenever you are going for this one, that is Ohm's law for electromagnetic field, right? What is the Ohm's law? If we generally apply the Ohm's law is V is equals to IR. For electric field, the Ohm's law is equals to J is equals to sigma E, sigma times E. This is called Ohm's law. So the current density J is equals to sigma times E. The answer is D. Next, electromagnetic waves are produced by. Electromagnetic waves are produced by. See, basically whenever we are going for the electromagnetic waves are produced by changing electric field, right? Changing electric field will, if you have a time varying electric field, that will produce a space varying magnetic field. If you have a space varying magnetic field, that will produce a time varying electric field. So that's why that is accelerating charge, which is time varying charge, you can say. If you accelerate the charge, it means that charge will vary with the time, right? So answer will be C. 10th question. An electromagnetic wave is going through the vacuum, and it's described by the equation E is equals to E naught sine of kx minus omega t, and B is equals to B naught sine of kx minus omega t. Then what we have to calculate, what is the relation is correct side, right? Electric field is given to you and magnetic field is given to you. So E naught upon B naught is going to be C. C is the light of speed, right? So what we can say, C is equals to omega naught upon K. K is the beta phase constant, you can say, right? So what we got here, you can check it here. See, that is E naught upon B naught is going to be C. So first thing what we have to check, is there any relation like this? No, that there is no relation, and this C is represents the phase velocity, and phase velocity is omega upon beta or omega upon K. So what we can say, that this A naught upon B naught is going to be omega by K. So here K times E naught is going to be omega times B naught. K times E naught is going to be omega times B naught, right? So which relation is correct? The relation is correct relation, right? Next, which of the following is not a Maxwell equation for static electromagnetic field in an isotropic and homogeneous? This time it is not a charge free medium, he says. See, basically which of the following is not a Maxwell equation? This is del dot B is equals to 0. This is Maxwell equation. Del cross D is equals to 0. From this equation we can go del cross E is equals to 0, right? That is for static electric field, magnetic field, and del cross H is 0. This is also Maxwell equation. This is not. This is not a Maxwell equation. So answer is A. Maxwell equation for electromagnetic is not applicable to which? See, whenever we are discussing about this Maxwell equation, then whenever your medium is moving, if your medium is constant, that medium is not moving, then your Maxwell equations are applicable. Now your medium is start moving, then your Maxwell equation will not work for that, right? Medium moving with respect to the system coordinates, right? Then your Maxwell equations are not applicable there, right? Next, a static field is irrotational whenever you have a vector that is irrotational vector. So for irrotational vector, del cross E or del cross A, any vector, if you have a vector A that is irrotational, that means their curl will be 0. So if your curl of a vector is 0, then we can say that it is a irrotational vector, right? So answer will be B. Next, the electromagnetic field is radiated from, again, electromagnetic field is radiated from, say, first stationary point charge, because whenever we are discussing about the electromagnetic field, EM waves, whenever we are discussing about the EM wave, the EM wave can be produced only by this del cross E is equals to minus del B over del T. Remember this equation. And del cross H is equals to JC plus del dot D over D, not B, D over del T. So these two equations are responsible for the generation of EM wave. So stationary point, it means we required a time varying field. So if you have a stationary point charge, that will not produce the EM wave. Capacitor with DC voltage, that is also not produced. A conductor carrying a DC current cannot be produced a time varying electric or magnetic field. That's why it is not. So an oscillating dipole will produce a time varying electric and magnetic field. The type of time variation del delta by E implies that reference to the field quantity in Maxwell equation, that is both sinusoidal and non-sinusoidal variations it will represent. It is not like that it is only represent the sinusoidal variation, it is represent both sinusoidal and non-sinusoidal variations, right? And electric susceptibility and relative permittivity are related with, see, basically there is a relation. This is called electric susceptibility. Electric susceptibility is epsilon r minus 1. That is the formula for electric susceptibility. So what will be the answer? Answer will be A. Relation between three vector E, P and D. See, this is from polarization, right? So basically the D vector is always equals to epsilon naught times E plus P. P is the polarization vector, right? So this is the relation between polarization vector, electric field and electric flux density. So D is equals to epsilon naught E plus P vector, right? Next is, in a twin wire transmission line in air, the adjacent voltage maxima are 12.5 centimeter and 27.5. The operating frequency, see, always remember when we are talking about the adjacent maxima in an EM wave or standing wave are lambda by 2 apart. If I am talking about adjacent maxima and minima, that will be lambda by 4. So basically he is talking about that you have a adjacent maxima that are this one and this one. So it means if we talk about lambda by 2, because distance between two adjacent maximas is lambda by 2, and that is going to be 27.5 minus 12.5. So when you subtract these one, we will got how much? That is going to be 15 centimeter, right? Because it is in centimeter. So lambda by 2 is 15 centimeter, lambda is going to be 30 centimeter. 30 centimeter, if I convert this 30 centimeter into meter, that is going to be 0.3 meter. Now F into lambda is equals to the speed of light, that is 3 into 10 raised to power 8. So from here we got the frequency, that is 3 into 10 raised to power 9 divided by 8 divided by 0.3. So this will cancel out, this will cancel out, then going to be 10 there, and it is going to be 10 raised to power 9. So what we can say, 1 gigahertz. 10 raised to power 9 can be represented as 1 gigahertz. So that will be the frequency, right? Next, the characteristic impedance neta naught in a free space. See, whenever we are talking about this neta, see, neta is under root of j omega mu upon sigma plus j omega epsilon, right? This is your neta. Now we are talking about the free space. Inside the free space there is no charge, there is conductivity is 0, right? It is a perfect insulator. We are assuming that if you have free space, that is a perfect insulator. So sigma is 0 and neta is become neta naught, and its value is going to be j omega cancel out, and mu can be replaced by mu naught, and epsilon can be replaced by epsilon naught. So neta naught is going to be under root of mu naught by epsilon naught, and this value is 377 ohm, or we can say 120 pi ohm, because it is an entrance impedance, that's why it is represented in ohms. So answer will be P. Next, the electric field component of a time harmonic EM wave is traveling in a non-magnetic lossless dielectric medium, has an amplitude of this one. This is the amplitude, okay. The relative permittivity of the medium is 4. The magnitude of time average power density. So if we talk about time average power density, that will be 1 by 2 E naught square divided by neta naught. So basically neta naught is free space, that is going to be not free space. So first we have to calculate neta naught, that is 120 pi under root, not neta, we are calculating the neta, right? 120 pi under root of mu r upon epsilon r. So epsilon r given you 4, so it is going to be 60 pi. So now we calculated neta, right? And E naught, the magnitude of electric field is how much it is given to you, 1 volt. So here we can calculate the average power density, that is going to be 1 by 2 1 square divided by 60 pi, right? So when you solve it, that is going to be 1 divided by 120 pi watt per meter square. This is called as power density. So these are the questions from the EMFT that will help you. Lots of questions are there. So if you want that complete video and complete PDF for this subject, because EMFT is not an easy subject, and you can get more questions from this one, because BEL exam is not like that you have to study it in depth. You have to study these type of question which I discussed today, right? You have to revise the equations and like that. See, so if you have the 17 days, you can make a plan for that one, that you have to solve in these 70 days more number of questions. If you are not start your preparation till now, you can start your preparation by solving these questions and revising the concept, right? And I will provide the complete video for the paid course also, right? This is the demo for you, right? There are several questions from these subjects, more like 100 and 200 questions, and from each subject you will get 100 and 200 questions in the form of video. So start your preparation right now and join YourPedia for this one. Thank you.